Right, so the question we are going to learn today is on prime factorization. So we are asked to find the prime factorization of 1599. So before I solve this, I want us to understand what prime factorization is. Assume I'm given the number 12 and I'm asked to find the prime factorization of 12. I'll first of all expand or rewrite 12 as a product of other numbers. Remember, 12 is 2 times 4 or 6 or 3 times 12 or whichever. Now out of this, 2 is a prime number, 6 is not a prime number. But prime factorization requires that all the product, that is all the factors, should be prime. So how can we write 6? 6 is again 2 times 3. So the expression 2 times 3 is the prime factorization of 12. Now let's come to the question we are asked. We are asked to find the prime factorization of 1599. But 1599 is quite a big number, right? So it will be very difficult for us to start expanding it or thinking of numbers that can go into this. Already we know that 2 cannot go here. To test if 3 can, add this up. This is 10, 19, 24. Yes, 3 can go into 24, which implies that this number is divisible by 3. But how many times can 3 go into this number will take us quite a long time. So how about we make use of difference of squares in solving this question? I want us, since this number is in thousands, I want us to recall some steps. 10 square is 100, 20 square is 400, 30 square is 900, 40 square is 1600, 50 square is 2500. Now if we take a look at this, the number 1599 lies between 900 and this. So it means 1599 is between 1600 and 900. So in order to write 1599 in another form, let us ask ourselves this question: 1599, is it much closer to 1600 or much closer to 900? Of course it is closer to 1600. So how many units can we remove from 1600 to give us back this number? So we know that if we remove 1 from 1600, it will give us 1599. Now let's expand this. 1600 is a square of 40, so this is 40 square. And we know that 1 can also be written as 1 square, that is 1 times 1 is still 1. This takes us to the idea of difference of square. Now the rule says that if I have a square and I have it minusing b square, this can be written as a minus b and a plus b. So if I have 40 square minus 1 square, this is going to be 40 is the a, so this is 40, b is 1 minus 1, and then 40 plus 1. So 1599 can be written as a square of 40 minus 1 and 40 plus 1. Now we know that 40 minus 1 is 39 and 40 plus 1 is 41. Before I proceed, I want us to confirm something. Remember, the product of these two numbers must give you back this. So this is going to be 41 times 39. I always use my expanded form. 41 times 30 plus 41 times 9. So if you multiply, this is going to give us 1230, and here this is going to give us 369. So let's add up 369 and add up, this is 9951. So it confirms that we are still on the right track. Now let's come back. Remember, the aim is to get the prime factorization. We are to end up with something of this form. So we have 39 times 41, and we confirm that it will give us back this number. But understand your prime numbers. 41 is a prime number, 39 is not a prime number. So how can we get two numbers that can multiply each other to give us 39? So we know that 39, add it up, it gives us 12. Since this is not ending with an even number, 2 cannot go, and since 12 is a multiple of 3, it means 3 can go into 39. How many times? 13 times 41. So the prime factorization, so if you take a look, 3 is a prime number, 13 is a prime number, 41 is a prime number, and this gives us the form we used as our sample. So 1599 can be written as 3 times 13 times 41. So this is the required prime factorization. I hope this was also useful.